Assalamu alaikum dear students. Today is our second lecture on carboxylic acids and its derivatives. So this is the last lecture we were discussing about carboxylic acid and it has derivatives. Let me change its background. Much clearer. So we have carboxylic acid and these are the derivatives. So last time we were discussing about the naming of carboxylic acids. We have 3-4 rules how to name carboxylic acids. Today we are going to start esters, then acid anhydride, acid chloride, acid amides. It has 2-3 types. So let us go one by one. Ester. In esters, this is the general form of ester. So R and R dash. It may be same, it may be different. So the point here, E of parent chain. Do you know what is parent chain? Parent chain is actually this ester is derivative. Derivative of what? Carboxylic acid. So we are saying here parent chain is basically carboxylic acid. It has been obtained from carboxylic acid. R C double bond O OH. This H has been replaced by R dash. That is why we are using here E of parent chain will be replaced by O8. Now the point is here we have R C double bond O OR dash. Which chain, where from we will start numbering? See, if we go to this R, suppose if we have here is oxygen, so oxygen is not counted because it will not be, we have to count carbon number of carbon atoms. So the possibility is from this carbon we have to start. No matter how many carbons are in this side, with this carbonyl group, we have to always keep in mind they will get numbering. And here if one carbon we have here attached, we will write it methyl separately. If 2 carbons ethyl, if 3 carbons propyl, whatever is there we have to write it as alkyl group. But here will be the O8 will be with this chain, no matter 2 carbons, 3 carbons, 4 carbons, 10 carbons. So let us start naming now. So if I say this compound here, C double bond O, please focus here, 1, 2, 3 carbons. Now then oxygen, 1, 2, 3, 4. No matter here are 4 carbon atoms, longest chain than this. But here is oxygen. Because of this oxygen we cannot consider this main chain, because this carbonyl carbon will not be included in this chain. That is why we have to consider this main chain. 1, 2, 3. So what will be the name? 1, 2, 3, 4. How many carbons? 4. Butyl. How many carbons here? 1, 2, 3. Propane. E will be replaced by O8. So butyl propanoate. Similarly here there is only one carbon, methyl, 1, 2, 3, 4, 5, 6, hexanoate. Deliberately I have given this first example like this, so that it will be clear to you. We don't have to count this chain. You just focus on oxygen. This side, oxygen, this side, it will not be counted, it will not be considered as main chain. Which will be considered as main chain? Where there is carbonyl carbon. This 1, 2, 3. So here will be 1, 2, 3, 4, butyl propanoate. Here will be methyl, 1, 2, 3, 4, 5, 6, hexanoate. Here 1, 2, 3, 4, butyl, 1, 2, 3, 4, butanoate. Okay, here 1, 2, ethyl, 1, 2, 3, propanoate. Here methyl, 1, 2, 3, 4, 5, 6, 7, heptanoate. Here ethyl butanoate. These are just for your information. These are generally not common. These are not the IUPAC names, but if you see esters, we are in daily basis we are using these esters in our food. Raspberry fruit, there is ester. Apple, there is ester. Butyl acetate. These are not the IUPAC names. These are commercial names. Pineapple, ethyl butyrate. Rum, these people who are whiskey rum, they are drinking this. There is ester. Peach, the fruit which we are eating, there is ester. Orange, Portugal, there is ester. We have wintergreen. You know, wintergreen is a red color, pinkish red color fruit like cherry. There is methyl salicylate. Honey, which we like to drink, which we like to take, so methyl phenyl acetate. Strawberry, ethyl methyl phenyl glycidate. So these are some commercial esters for your information. Acid anhydrides. Acid anhydrides has 2 types. One is symmetric, another is unsymmetric. In symmetric acid anhydrides, parent chain name is added with anhydride. Parent chain name, suppose we have 1 2 3 1 2 3, so both sides are same, it means this is symmetric. Both sides are same, symmetric. If both sides are not same, we are saying unsymmetric. So first let us go through symmetric acid anhydride. So 1 2 3, how many carbons? 3 carbon. So instead of, because both it is symmetric, we are using it one time. So propanoic anhydride, just add anhydride. How many carbons? 3. 1 2 3. Propanoic, because the parent chain means carboxylic acid, because it is derivative of carboxylic acid. So propanoic anhydride. Here 1 2 carbons, same here. So ethanoic anhydride. Here 1 2 3 4, 1 2 3 4. So butanoic anhydride. Here 1 2 3 4 5, pentanoic anhydride. So these are symmetrical acid anhydrides. You can write symmetrical acid anhydrides. Now if we have unsymmetrical acid anhydrides, here it is unsymmetrical. Okay, unsymmetrical acid anhydrides means the both sides are not same. See here 1 2 3 carbons, here 1 2 3 4 carbon. Now here it means it will be, the parent chain will be here 1 2 3 propanoic acid, here 1 2 3 4 it will be butanoic acid. Now which one will come first? Here we will go through alphabetical order. So first will come B, butanoic, then propanoic. So butanoic space propanoic, then at the end anhydride. So first naming each component carboxylic acid alphabetically arranged without the word acid. Suppose butanoic acid, this acid we have to delete, we don't have to write acid. Similarly here followed by space and then word anhydride, then we have to add anhydride at the end. So here 1 2 3 4 butanoic, here 1 2 3 4 propanoic, space then anhydride. If you see here 1 carbon 2 carbon, here 1 2 3, so this 3 will be propanoic, this 2 will be ethanoic. So use now alphabetical order, first will come E, then come P. So ethanoic, propanoic, anhydride. If you see here 1 2 3 4 5, 1 2 3 1 2 3 4 butanoic, pentanoic. So first B, then P, butanoic, pentanoic, anhydride. Here 1 2 3 4 5, 1 2 3 4 5 6 7 8 O, octanoic. First will come O, then will come P, octanoic, pentanoic, anhydride. Now acid halides. When I say acid halides, it will include both chlorides and bromides. Generally these two are well known acids. Acid halide includes generally chlorides and bromides. The ic, you know where from it is? From carboxylic acid. So ic acid ending is removed and replaced with the ending il. We have to add here il. If it is feeling, you will feel difficulty by this, just remember this. E will be replaced by il, OYL. Yeah, you can write like this. E will be replaced by OYL, oil halide. This is simple also. So acid halides, acid chloride, acid bromides. The ic acid ending is removed and replaced with the ending il. Yeah, you can say E will be replaced by oil halide. Halide means now chloride or bromide, followed by the name of the halogen with an ide ending. So for example, we have here 1 2 3 4 carbons. So it will become, suppose 1 2 3 4 carbon, butane. So you can write, suppose if you use simple way, butanyl, add OYL, E replace E by OYL, butanyl. Now there is chlorine, it will be chloride. Yeah, you can say butanoic. See, if you see here, butanoic acid is the parent, because 1 2 3 4 carbons. So ic acid, this is first rule, ic acid is replaced by YL, then halide chloride, so it will be butanyl chloride. I think the second one will be much easier for you. E will be replaced by oil. So 1 2 3 4 5 pentane, replace E by OYL, oil, pentanyl bromide. So because here is bromine. Hexanyl chloride, decanoyl chloride, heptanoyl chloride. Then acid amides, the oic acid ending of the corresponding carboxylic acid is replaced by amide here. So we are gonna to replace here oic acid. Oic means we are using this as a parent chain. Suppose 1, 2, 3, 4, 5, 6. 6 carbon means hexanoic acid because parent. But we have to remove this oic acid and add amide. So hexanamide. You can directly say remove E. E will be replaced by amide. This is simple. E will be replaced by amide. So we have here 6 carbon, 1, 2, 3, 4, 5, 6. So hexanamide. 1, 2, 3, 4, 5, 6, 7, 8. Octanamide. Now if you see here, this nitrogen is attached with hetero. Here is NH2, we have no issues, no problem, because this is a simple primary. If it is secondary amine, now secondary amide NH, but here is methyl. So we have to mention here N-methyl. Then how many carbons? 1, 2, 3, 4, 5. Pentanamide. Exactly. Only you have to add here what is attached with this N. Here N attached with 2 carbon. 1, 2. So here this is tertiary. So tertiary amide. So we will write N-ethyl. We have 2 attachments here. This is ethyl. This is methyl. So we will go here alphabetical order. First will come E, then come M. So N-ethyl. N-methyl. How many carbons? 1, 2, 3, 4, 5, 6, 7. Heptanamide. Here we have 1, 2, 3 carbons. So propyl. Here phenyl. So now if you see PRO, propyl. PHE, phenyl. So if you see first word is same. PP. Here is P. Here is next word R. Pro R. Here is PH. You got it. So this will come first. That is by N-phenyl and propyl. Then how many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonenamide. This is the naming of carboxylic acids and their derivatives.